This example shows the practical application of Bayes' theorem in a business scenario. Consider the past data indicating that 10% of the credit card holders defaulted, leaving the credit card company unable to collect the money. Then the credit card company knows also that the probability of missing a monthly payment is 20% or 0.2 for customers who do not default. And note that the probability of missing a monthly payment for those who default is, of course, 1. Now, with this information, the credit company has to recall its card if the probability that a customer defaults is greater than 0.15 or 15% chance. Given the above, should the bank recall its card if the customer misses a monthly payment or not? Okay, so what we have in this question, in this set of information provided is past data indicate 10% of credit card holders defaulted. So basically unconditional probability or initial probability. So initial probabilities, or basically the prior probability, unconditional, says probability that customer or cardholder default or goes bad, let's say, is 10%, 0.1. Okay, now it says the credit card company knows that the probability of missing a monthly payment is 0.2 for customers who do not default. So the probability that customer misses the monthly payment, let's say missing the payment. So M indicates missing payment. It says P of M given customer is good one. So is a good customer, is not default customer. Okay, so is equal to 0.2, 20% chance. And of course, remember that the probability of being a good customer is 1 minus the probability of being a bad customer. So the one that the probability that the customer does not default, 1 minus the probability that the customer defaults, so 1 minus 0.1, which is 0.9. So 90% of customers are good one, not defaulting. Okay, and the last portion of information is note that the probability of missing a monthly payment for those who default is 1. So the probability of missing, given that it's a bad customer, defaulting customer, is 1. Okay. The credit card company has to recall its card if the probability that a customer default is greater than 0.15. So that is our threshold. Should the bank recall or not if the customer misses? So what we need to do is we need to first compute the revised or posterior probability. What do we mean by that? It means the probability of the defaulting, which means becoming a bad customer, given that monthly payment is missed. So this is what we are looking for. So unconditional 1 is the prior, and it's 0.1. But now, given that the monthly payment is missed, we want to see or compute that what is the chance that it's a defaulting customer or the one that is going to default and be a bad customer. So that's the question. The conditional probability, which means the posterior. So conditional probability, which means the posterior or revised probability. So what is that? Well, we're going to use the formula for conditional probability, which is P of, say, B, joint probability of B and M over the probability of M in denominator. And of course, this becomes P of B and M, the joint probability of B and M, P of I mean, you can write it just for the sake of ease of seeing it. It doesn't matter. You write it M and B. And of course, in denominator, you have M and B plus the probability of M and not B, which means M and good, because the customer is either going to default, which means B, or not default, which means G. Okay, so the last step here is the numerator can be, using multiplication law, can be just rewritten as P of M given B times B of B. So I'm going to just replace or substitute for numerator as P of M given B times P of B. And as you can see, we have a repeat of numerator and denominator, which means P of M given B times P of B. And then for the second component in denominator, I can just write it P of M given good times P of good. Okay, so now we just need to plug in P of M given B. Let me use a different color. So P of M given B, this portion is what we know here. And of course, P of M given G, also what we already know. And P of G is also computed here. So we're going to just substitute P of M given B is 1. P of B is P of B is 0.1 here. And P of M given B is 1.1. And P of M given G is 0.2. P of G, this is G, is 0.9. Okay, so what we obtain is 0.1 in numerator, and in denominator we have 0.2 times 0.9, which is 0.18. So this one is 0.18, and then this one is 0.1. So it becomes 0.28. So we get 10 over 28, which means 5 over 14. Okay, so what is that? We found that what we found is P of B, or customer going to default, given that we know monthly payment is missed, is now computed to be 5 over 14, which is obviously above the threshold we are concerned about, because 5 over 14 is equal to 35.70, roughly 31 point. So is roughly 31.71%. And you can see that this is by far greater than the threshold of 0.15 or 15% that was mentioned to be the tolerable range, since this revised or posterior probability computed using Bayes method is much higher than the threshold of 15% or 0.15. We better not mention it in percent, just to be concrete. Let's keep it as just 0.317, and is much higher than the threshold of 0.15 that we wanted. Therefore, it means this card holder, the card should be recalled. As soon as the monthly payment is missed, there is a very high chance that the customer is going to default, much higher than the acceptable threshold. So the bank or the credit card company needs to recall the card. I hope that this example is helpful in terms of how we can use Bayes theorem, Bayes method, to find the revised probability for a business decision.